All right, so howdy. So this is another couple of examples on probability. So I'll put up a link, okay, to kind of the playlist for these if you want to see more examples. So what is the probability of pulling 4 straight aces? Assume no replacement, and then there's 52 card deck. So if you are trying to pull 4 straight aces, good luck, okay, and 4 straight, okay, with no replacements. Okay, so this is how we could solve this particular problem. So you are going to pull a card, okay, out of a deck. Now, so we want to know what the probability of pulling an ace is, okay, on the first attempt. So there's 4 aces, right, in a card of 52. So you're going to have a probability of 4 over 52, okay, if this is an ace of some kind. Now, there's no replacement, so we're not putting the cards back in. So now that means on the second attempt, so as you pull up another card, you want another ace, but now you don't have as many aces left, right? Because you're assuming that you've pulled 1 ace out. So on your second attempt, you only have the possibility of 3 aces, okay, out of 51 cards. Now, why is it out of 51? Because you already pulled 1 card out. So the probabilities, okay, is now has shifted, okay, in terms of the number of cards that you have left and then the number of aces that you have left. So on the third attempt, so what you would have, so if you wanted another ace, well, now there would be only 2 aces left out of 50 cards because, again, you pulled 2 cards out already. And then you can see that on the last one, if you wanted an ace, it would have been only 1 out of 49. So those probabilities keep kind of going down as you pull the aces. Now, they're all independent of each other. So what we would do is we would multiply these together, and then we would get what our probability is. And you can then change it back into percent if you wanted to, or keep it as whatever you like. So 4 times 3 is 12. 12 times 2 is 24. So that's at the bottom. And then at the top, numerator, and then at the bottom, so we have 52 times 51 times 50, and then times 49. So you'll notice that this is really difficult to do. So that is your probability. Now, if you wanted to change that back into a percent, so this is 24, all right, divided by, so 6,497,400, and it's a tiny amount, times 100%, because we want to change it to percent. So this would have been 0 point, and then you have 1, 2, 3, and let's round this off. So we would have that. So very tiny amount. And that is indeed, okay, so it's highly unlikely that it will happen. It's possible, okay, but that's the probability. Okay, so that's example number 1. Example number 2 is, what is the chance of pulling a non-face card from a deck of 52 cards on 2 consecutive draws? Assume no replacement. So this is a similar problem, but we want a non-face card. So, well, the face cards are jacks, queens, and kings, right? And we have 4 of each. So that means if we were trying to do this, now luckily this is only in 2 consecutive ones. Okay, so we have that. So jacks, queens, and kings are my face cards. So in 52 cards, so in the first draw, so 52, okay, to try to pull out, so that means I'm going to pull out either an ace or a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9, or a 10, right? So what does that mean? Okay, so that means, so ace and then 2, 1, 2, 3, all the way up to 10. Okay, so that's, 10 different cards. Okay, and then there's 4. Okay, so 4 of each. So what this is saying is that we have, so either an ace, a 2, a 3, a 4, a 5, so on, up to a 10. And we're saying that there's 4 of these, okay, and 4 of these, and 4 of these, and so on. Okay, so notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 different types of cards, 4 of each. Okay, so there's 40 in total. So on the first attempt, okay, of your card, you have 40 out of 52. On your second attempt, now because we have no replacement, so this is going to be 39 over 51. And we have to multiply these two together to get our answer. So what is that equal to? So 40 times 39, so 1560. And then we have 52 times 51. So that's going to be 2652. And then we can get this as a percent in terms of probability if we wanted to. So that's going to be changing it back down. So approximately, so let's say 59%. All right, so that's what our probability is. So that's interesting. All right, so those are the two examples. That's how you can tackle them. All right, so thanks for watching. See you in a future video. Bye, everybody.